Now single phase full wave converter with RL load. We can achieve continuous and discontinuous modes of operation by varying the value of alpha, as we seen in the previous topic, that is single phase full wave converter with R load. The link is given in the description, please go through it. Or depending upon the value of the inductor also, we can achieve continuous and discontinuous modes. Discontinuous mode where the load inductor L is small. Then the voltage is given in positive half cycle, T1 and T2 forward bias, and T3 and T4 are in reverse bias. When the supply is given and T1, T2 are fault, the current flows from A to T1, T1 to the load, that is RLE, to T2 to B, comes back to the source. T1, T2 are fault at omega t equals to alpha. Input voltage is going to appear across the output at omega t equals to pi. Even though the input voltage becomes negative, there exists a current due to the inductor L will get a negative voltage appear across the output. This term is going to depend upon the inductor L. Since it is small, it's going to appear for a while up to beta, which is known as delay angle. Then goes to 0 as the inductor stops discharging. Then the voltage across the output will become 0. In negative half cycle, when omega t equals to pi plus alpha, T3 and T4 is going to turn on as they are in forward bias, and T1, T2 is going to turn off as they are in reverse bias by natural commutation. Then the voltage across the input is going to appear across the output, and this is a period where T1, T2 is on, and this is T3 and T4 is on, and this negative spike is due to the inductor. Then the similar thing is going to happen even after the 2 pi. Due to the inductor, negative peak is going to appear across the output. Here also we can say that there is a negative peak. This delay time beta is going to depend on the value of inductor L. The input current is going to present whenever the circuit is in operation. So this is our input current. Then the output current is going to present whenever the input current is present. But the current in the output terminals is going to flow through the RLE, or from C to D. In the negative half cycle, T3 and T4 is turned on. The current flow direction is B to T3, T3 to RLE, then T4 back to the source A. Current here from R to E, here also R to E. So the output current will be present in positive only. You can see from the output waveform that output current is discontinuous. Now average output voltage, that is VDC, for this circuit is given by 2 by 2 pi, that is 2 times it's happening here, integral alpha to pi plus beta Vm sine omega t d omega t, Vm by pi minus cos pi plus beta plus cos alpha equal to Vm by pi cos alpha minus cos beta. This is our VDC. RMS output voltage is V RMS equals to 2 pi alpha to pi plus beta Vm square sine square omega t d omega t whole to the power of 1 by 2. Then we'll be getting 1 by pi Vm square integral alpha to pi plus beta sine square theta equals to 1 minus 2 cos omega t divided by 2 d omega t under the square root. Now this Vm square by 2 pi, now 1, if you integrate, you are going to get pi plus beta minus alpha minus cos 2 omega t, sorry, then sine 2 omega t divided by 2, then omega t I need to substitute, that is pi plus beta minus sine 2 alpha by 2 whole to the power of 1 by 2. Then I am going to get Vm square by 2 pi, that is pi plus beta minus alpha plus sine 2 beta by 2 minus plus sine 2 alpha by 2 is all under the square root. Then V RMS equals to Vm by root 2 1 by pi of pi plus beta minus alpha plus sine 2 alpha by 2 minus sine 2 beta by 2 under the square root. These are V RMS. When the load is highly inductive, or else delay angle is greater than or equals to alpha. In the positive half cycle, the input voltage is going to appear across the load as T1, T2 are turned on due to the forward bias. Then at omega t equals to pi, the input voltage becoming a negative voltage. In that, the negative spike is due to the inductor. The inductor is highly inductive, which means the beta is equals to or greater than alpha. Then this negative value is going to present, or the voltage is going to conduct up to the alpha, since here beta equals to alpha. At alpha, the T3 and T4 again turned on, so it's going to follow here also. It's going to follow like this. Here we are getting a more negative spike as delay time is equal or greater than alpha. Then input current always is going to flow through the circuit as the circuit is connected always. This is how the input current flows. Then as the input current is available, the output current is also available at all the times and gives us a continuous output. This is how we'll achieve continuous mode of operation. The VDC or average output voltage is given by, now I'm considering the complete 2 pi value, so 2 times it is repeating by 2 pi integral alpha to pi plus alpha, since alpha equals to beta, Vm sine omega t d omega t. Now Vm by pi minus cos pi plus alpha plus cos alpha. VDC equals to Vm by pi minus cos pi plus alpha is cos alpha plus cos alpha is 2 cos alpha. This is the average output voltage. Output voltage will be maximum at cos alpha equals to 1. That will be, if the cos alpha is 1, then 2 Vm by pi. Then the normalized voltage is given by the average output voltage divided by the maximum voltage. Then this one divided by this one, we are going to get a cos alpha. This is normalized output voltage. V RMS or RMS output voltage is given by 2 by 2 pi integral 0 to pi plus alpha Vm square sine square omega t d omega t under the square root. Now if you solve this, then you are going to get Vm square by pi integral alpha to pi plus alpha plus 1 minus cos 2 omega t by 2 d omega t is the whole thing under the square root. Then 2 comes out, then Vm square by 2 pi. Now 1, if you integrate that, then you are going to get pi plus alpha minus sine pi plus alpha by 2 plus sine 2 alpha by 2 under the square root. And pi gets cancelled. Here also minus sine 2 alpha by 2 plus sine 2 alpha by 2 gets cancelled. Then you are going to get that V RMS equals to, this is whole thing is under the square root, so Vm, and here only pi is remaining in this, so pi gets cancelled. Then Vm by 2 is under the square root, so root 2. This is our RMS output voltage.